Hi, I'm Stefan Lenz, Application Scientist at Chemical Computing Group. In today's session, we'll use the filter database application to filter a dataset of compounds containing COX-2 and COX-1 activity data. The goal is to quickly identify compounds that are selective for COX-2 while also having good properties. We'll start by importing our data from a CSV file into a Mo database. As I click OK, I'm prompted with the database import panel. Today, I'll accept the defaults and import my data. I can see that in my database, I have 648 different entries and I have 5 fields. A field for the ID, the 2D structure derived from a SMILE string, the chemical series, and PIC50 activity values for both COX-2 and COX-1. Let's use the filter database application to carry out interactive multivariable filtering. So here I have control of the application of my filters both globally as well as individually. I see that histogram filters have automatically been created showing the distribution of COX-2 and COX-1 activity data. And at the bottom, it indicates that 98 of 648 entries will remain after applying the filters, as empty cells are automatically filtered. So I'll press apply to filter out entries without both COX-1 and COX-2 activity data. If I'm interested in where I'm missing data, I can always click on invert to see those compounds. Next, I'll use the sliders to identify compounds that are selective for COX-2. So I can manually manipulate the slider, or I can click into the text box and specify a specific value. So here we'll display only compounds that have at least a value of 6 for COX-2 activity. Similarly, we'll adjust the COX-1 activity so that we'll only display compounds with a maximum COX-1 activity value of 6. Next, we can add in a categorical filter for the chemical series. And what this shows is that most of my data comes from the 5 aromatic series. If I toggle that off, I can see that I have 3 compounds from the 5 aliphatic series. And if I toggle that one off, I can see that none of my compounds come from the 6 aromatic series. Next, let's use descriptors to help us select compounds with desirable properties. So I'll navigate to the Calculate Descriptors panel and add in some interesting descriptors like S log P, molecular weight, and the number of rings. And as I click OK, these descriptors will be calculated for my database. Next, I can plot the descriptors using a correlation plot to help me identify selective COX-2 compounds with desirable properties. So I'll change the X to be S log P, the Y to be the molecular weight. We'll color based on the COX-1 activity, so purple indicates low activity and red indicates high activity. And we'll also size based on COX-2, so the bigger the data point, the more active that particular compound is towards COX-2. In the lower left-hand quadrant, we have compounds with low molecular weight and low S log P. This compound in particular looks interesting because it has desirable properties and it's selective for COX-2. If I just hover my mouse over it, I can see the specific values of each property as well as the 2D structure. On the other end of the spectrum, I have compounds with high S log P. Some of them also can have high molecular weight. And they also might contain many rings. So let's create some filters to remove these compounds with undesirable properties. So I can create filters using any of the descriptors that I calculated a moment ago. I can filter out compounds with high S log P. So here we'll display only compounds with a maximum S log P of 4.5. Similarly, we can filter out the compounds with higher molecular weights. So now we'll display compounds with a maximum molecular weight of 450. I can compare compounds with 4 rings, and after applying my filters, I can see that I have 3 compounds with 4 rings, and they don't have too terribly interesting properties or activity values. So I'll also apply a filter so that I only see compounds with 3 rings. After applying my filters, I can see that I have a total of 37 compounds remaining, and these are all compounds that are visible within the database viewer. As a reminder, these compounds all have a COX-2 activity value of at least 6, COX-1 activity value below 6, 3 rings, and S log P values below 4.5. So these compounds can now be selected and saved to a new database for further analysis. And that brings us to the end of today's session. We saw how the filter database application allows for interactive multivariable filtering of database entries. Histograms show the value distributions for numerical fields to allow for analysis of the dataset statistics, while checkboxes enable filtering of categorical data. Together with the database viewer and the plot window, this creates an interface for data visualization, analysis, and filtering. So I hope you've learned a lot. If you have any questions, please do reach out to me at support@chemcomp.com.